Now in this video we will check how to apply conservation of energy to elliptical orbits. So again we take an elliptical orbit and we denote the velocity at the two different positions VA and VB. The distance from the focus is RA and RB. Now conservation of energy says that total energy at A will be equal to total energy at B. Energy is kinetic energy plus U, so we substitute that. Kinetic energy at A plus potential energy at A equal to kinetic energy at B plus potential energy at B. Substitute the formulas to get this expression. Do not forget the gravitational potential energy for this system is negative GMM over R, and according to the position we will write RA and RB. We can cancel M throughout, we will get this expression. We can solve the equation for VA. Taking GM over RA to the other side makes it positive. Then we can multiply throughout by 2. And then we can take the square root to get the value for VA. We need to solve this equation based on the formula which we just now derived. It says a space probe is fired as a projectile from the Earth's surface with an initial speed of 2 × 10⁴ meter per second. So that's the initial speed. What will be its speed when it is very far from the Earth? So let's check. The formula which we derived is this. We write the data which is given. ME and RE is the mass of the Earth and radius of Earth which will be provided. Now let's check the initial distance is RB, which is 6.37 × 10⁶, because it is projected from Earth's surface, and the final distance is infinity. It says very far, so we'll take it as infinity. So 1 over RA will be equal to 0. We substitute the values in the formula and we get the value for VA.